Let's talk about an icon. A building that didn't just redefine a skyline, but an entire nation's ambition, the Petronas Towers. Yeah, for a while, they were the tallest buildings on the entire planet. But their story? It's about so much more than just height. It's a fantastic tale of culture, an intense competition, and some absolutely colossal engineering challenges.
Okay, so let's get right into this. The whole point here wasn't just to build another office building. No way. This was a statement. Malaysia was basically announcing to the world, we're here, we're a global player, and these twin giants, they were meant to be the country's unmistakable signature. But to pull it off, they'd first have to conquer the very ground beneath their feet.
So here's the big question for the architect Cesar Pelli. How do you design a 21st century icon that feels deeply, authentically rooted in ancient tradition? The answer, it turns out, wasn't about copying the past. It was about translating its most important principles into a modern marvel.
Now, this is really the key to the whole design. The entire footprint of both towers is based on this one symbol, the Rub el His. It's this beautiful geometric pattern that represents core Islamic principles like harmony, order, and stability. And trust me, stability would become a major theme for this project. And this is just a brilliant move. Pelli took this two-dimensional symbol and just extruded it, pulled it straight up, 88 stories into the sky. And what you get is this stunning, multifaceted shape that just glitters in the sun. It's a totally postmodern skyscraper, born from an ancient, sacred design.
But while the vision for the towers was soaring into the clouds, the reality on the ground was, well, let's just say it was a disaster waiting to happen. Before a single floor could even be built, the engineers stumbled upon a hidden crisis that threatened to kill the entire project right then and there.
You know, on the surface, the old racetrack site seemed like the perfect spot. But the one question engineers absolutely had to answer was, what are we actually building on? And the answer they found was anything but simple, and it was definitely not stable. So the first survey comes back, and it's a total nightmare. Turns out the site is literally on the edge of an underground cliff. One side is decayed limestone, just riddled with holes and cavities. The other side, soft, unstable rock. Trying to build the world's tallest towers here was like trying to balance a needle on a wet sponge. The risk that one tower would sink faster than the other was off the charts.
So what do you even do in a situation like that? Well, the first incredibly dramatic solution wasn't to dig deeper. It was to move. They shifted the entire planned location of the towers by 61 meters. That's about 200 feet, over to a patch of ground that was still soft, but at least it was consistently soft. I mean, what a massive decision. It just shows you how serious this problem really was.
Even on this better ground, the foundation they needed was just monumental. We're talking 104 massive concrete piles for each tower, some of them going down 114 meters deep. Then, for the giant concrete slab on top, they had to pour concrete continuously for 54 hours for each tower. That was a world record at the time. This wasn't just a foundation. They were literally building their own artificial bedrock.
Okay, so with the foundations finally secure, the focus could shift from going down to going up. And to hit a really aggressive 6-year deadline, the whole project got turned into a high-stakes competition. 2 rival teams, 1 for each tower, in an all-out race to the top.
So you've got a Japanese consortium building Tower 1 and a South Korean team building Tower 2. And the prize for finishing first? It wasn't just bragging rights, no. The winner got the contract to build the iconic sky bridge that would connect the 2 structures. The race was officially on. The South Korean team was absolutely flying, pushing hard to win. They made it all the way to the 72nd floor, soaring high above Kuala Lumpur. But then, a routine measurement check revealed an absolutely terrifying problem.
The tower was leaning by 25 millimeters. Now, that's barely an inch, and at ground level, who cares, right? But when you're 72 stories up in the air, a tiny lean like that could mean catastrophic failure for the entire building. The race came to a screeching, terrifying halt.
The fix for this required just incredible precision. For the next 16 floors, the engineers had to intentionally build them with a tiny slant in the opposite direction, slowly, carefully correcting the lean. Surveyors were checking the verticality twice a day, every day, until finally, by the time they reached the top, the tower was perfectly straight. What a save.
Now, despite that scare, the South Korean team did finish their tower first, and they won the right to build the single most famous feature of the Petronas Towers, the Sky Bridge. This wasn't just going to connect the two buildings, it was going to make them legendary.
So this thing hangs between the 41st and 42nd floors, about 170 meters, that's 558 feet, straight up. It's an absolutely breathtaking sight for sure. But the most incredible thing about it isn't actually its height. The real genius of the Sky Bridge is how it's built. See, skyscrapers this tall aren't perfectly rigid. They're designed to sway in high winds, but they don't always sway in the same direction at the same time. So the Sky Bridge isn't rigidly bolted to the towers. Instead, it rests on these huge bearings that let it slide in and out, basically acting like a shock absorber and letting the two towers dance in the wind without tearing the bridge apart. When they were finally completed in 1998, they officially took the title of the world's tallest buildings. They held that crown for 6 years until Taipei 101 came along. But even today, they hold on to a really unique record. They are still the world's tallest twin skyscrapers. So when you look at the whole story, from conquering that impossible ground with the world's deepest foundations, to racing to the sky and fixing a near-disaster midair, and then linking it all with that amazing sky bridge, the Petronas Towers became so much more than just buildings. They really became a symbol of what human ingenuity can achieve.
And it all comes back to this question. It seems that building a legacy that truly touches the sky isn't just about how high you can build. It's about having a foundation, both culturally and, of course, physically, that's strong enough to support that kind of incredible ambition.